Hi, my topic is about face recognition. First, let me introduce the procedures of the face recognition. A complex and a delicate face recognition always includes four main procedures. The first one is face recognition, face detection, which is the face and landmark localization. Then we need to align the faces. So it can to extract the feature we want to get and to do the last step, feature matching. And in my project, I mainly research about the feature extraction and the feature matching. Then let me introduce the present situation about the feature recognition. Feature recognition is very popular and it is widely used in different applications like payment and security. And there already have a lot of techniques of the facial recognition. And some people use agent faces, principal component analysis, linear discriminant analysis, and the convolutional neural network, which is CNN. And the CNN is the most popular one in the face recognition field. Then I want to introduce about the convolutional neural network, which is CNN. The CNN consists of several convolutional layers and a deeply connected layer, and then an output layer. The convolutional layers is the most important layer in the CNN, and the ability of the CNN to discriminate features is greatly dependent on the convolutional kernels. And the convolutional kernel is set in the convolutional layers. Pruning layers are used to reduce the dimensions of the input information, and a fully connected layer is used for connecting the last layer to the next layer. Output layer is used for output the results. Then I want to introduce about a kind of latest development, which is DeepID. DeepID already have 3 generations, and here I introduce about the first generation of the DeepID. DeepID is a face recognition method which has a one-to-one relationship between the task and target, and it uses a very large data set to train the data model, which contains 10,000 faces in the training dataset. And the structure of the DeepID is as the figure. It has 4 convolutional layers, a deeply hidden identity feature layer, and a soft mask layer. This first generation of the DeepID can already have an accuracy of 97.45% on the dataset, the label face in the wild dataset. And when the training dataset gets larger, the accuracy of the DeepID will be higher too. And then I want to introduce the FaceNet, which is developed by the Google. It is different from the DeepID because it removed the soft mask layer. It directly mapping the face image to the compact Euclidean space, and it used the novel online triplet mining method to train the data model. So the selection of the triplets can lead to the faster computation. And it also achieved a new record, which is an an accuracy of 99.63% on the label facing the Y dataset, and it can achieve 95.12% on the YouTube face database. Then I want to implement my demo. First, open the path. And implement the train file. The training and validating dataset have 1,100 faces of different people from the LFW dataset. They have been processed into a folder to input into the file. It will take some time in training, but since the dataset is not so large, so the time will not so long. It will take 1 minute or so. Okay, the training has finished, and it took 1 minute and 42 seconds. Then we can implement the task file, which abc.jpg is our target, and we want to see whether we can identify the target. Okay, because here our input is EFG, which is not my target, so the input is false. And no matter how many times I implement the test file, it also said it's false. Then we change the path to our target. And run the test file. Okay. It said, is this the target is true? So the notation here is finished. And then to evaluate my implementation. This is the accuracy line. I got this from the TensorBoard. It can show that as the times of training increase, the accuracy is going up. But at first, it's really low and it will oscillate a lot. And this line is the loose curve. The loose curve for the data model is getting lower and lower when the training time is growing. So we can prove that the CNN training for the data model is useful and productive. My presentation is done.